Now what I'm going to do here is change these regular numbers into standard form, and when we do that we need to have the decimal place immediately after the first non-zero digit, which here is 2. So the first thing I do is write down 2.68 times 10, and the trick here is really to work out what the power is here. Here I've got another number, and the first non-zero digit is 7, so the decimal place needs to go here, and so I'm just going to write down 7.05 times 10, and I'm going to work out what the power is later. Okay, so just showing you how to make the first bit of the standard form is go to the first non-zero digit and write down 5.03 times 10 to the power something. Okay, well now it's time to work out what those powers were for those 3 questions, and I'm going to put some jumps in. So I put the decimal place here, and it was here, so 1, 2, 3, 4, 5. Okay, so I've moved the decimal place forward. Okay, if I've moved the decimal place forward, then I've made the number go backwards in place value, and so this needs to be multiplied by a large power of 10, 10 to the power 5, in order to compensate for the fact that this large number has now become a small number. I'm making the number bigger by times 10 to the power 5. Well, here we can just quickly check on the calculator. 2.68 times 10 to the power 5. Okay, and you can see that I've got 268 with 3 zeros, which was the original thing, so I've got it right. Well, let's compare this number 7 in the units column to the 7 in the thousandth column. Obviously, this number has become a lot bigger, and because I've made this number bigger, I need to make it smaller again. And the way to make it smaller again, okay, is to use a negative power. If I use, well, let's see how many jumps that was to get it there. Okay, you can see that was 3 jumps, so I need to make it 10 times small. I need to divide by 10 3 times, because this is effectively dividing by 10 3 times. Okay, here we can try see if the calculator will confirm whether we got it right or not. So if I do this 7.05 times 10 to the minus 3, okay, if I do that, press equals, problem, right? Okay, this one doesn't do it for us, unfortunately, so we're going to have to do it ourselves. And so what I'm going to do is I'm going to take my answer and try and reconvert it into a regular number in order to check it. So this was 7.05, and if I want to divide by 10 3 times, I move the decimal place forward, and that would give me here, and I'd get 0 0 0. Okay, 7 disappears from here, 0 0 7 5. See, that's good, because that it was the original thing. So in fact, this must be correct. Okay, here I've divided by 10 3 times, here I've multiplied by 10 5 times. Let's look at this one. The 5, okay, the 5 used to be really big and now it's small. When I look at the number of jumps, well, the number of jumps is there, 1 2 3 4 5 6 7 8. Okay, so I just need to think to myself, okay, is this 10 to the minus 8 or 10 to the 8? Well, it's 10 to the 8, and the reason it's 10 to the 8 is because this number has become small, and so we need to compensate. We need to make it bigger again. And fortunately for us, for those types of ones, the calculator is going to be helpful. If I do 5.08 times 10 to the power 8, okay, we do get the number that we previously had, so 5.8. Can I just about see that there? Okay, so that's good. That's good one. Let's have a look at this. It's very small number. So I'm really because it's small, I'm expecting 10 times 10 to the power of a negative power. Okay, this bit's easy because it's just 7.3. But the decimal place is just after the first non-zero digit. Okay, how many jumps did we do? 2 3 4 5 6 7 8 9. Okay, so I've actually made this number. This is a very, very small number, whereas 7 is in the units column. And so the only way to make that smaller again is to divide by 10 9 times. Let's look at this one. Here we're going to get 9.9, 1, 2, 3, 4, 5, 6, 7 times 10 to the 7. Okay, and again, that's one you could check on your calculator.